everyone, so it's Coach Fred here, and today I'm going to be talking about graphing inverse functions. So up to now you've learned what inverse functions are, what they do, how we determine if two functions are inverses, now we're going to look at the graphs, okay? Now I want to make sure that we clarify whether, an equation can have an inverse, right? That doesn't necessarily mean, though, that the inverse is a function, right? We've got to make sure that we understand that. So a lot of our functions, we've talked about the fact that we have to kind of restrict the domain, meaning the inputs we can put in. Here's a great example. I've given you the graph of f of x squared plus 3. So we have a quadratic function, okay? So I'm actually just going to pick a couple of points on the graph. I'm going to, pick a few points. So, for example, I've got negative 2, 7, and then 2, 7. I've got negative 1, 4, and I've got 1, 4. I didn't give myself enough room, so let me redraw that. I'll do it over here. So negative 2, 7, negative 1, 4, 0, 3, 1, 4, 2, 7. Okay, so that's the function. If I want to graph it by using the line of symmetry, first we have to know what that line of symmetry is. So you may recall from the previous videos that I said that inverses are going to reflect over the line y equals x. That should kind of make sense to us because when we write the inverse equation, we just flip the x's and the y's. Okay, so I'm going to plot these points. So negative 2, 7. So up here somewhere, negative 2, 7. Negative 1, okay, 4. I'm just going to make these a little bit more pronounced. 0, 3, 1. Okay, so I've got these points like nicely drawn. So if I want to get the inverse, I'm going to flip the points. Okay, so I'm going to do the inverse. I'm going to actually use the notation that we learned about, the inverse function. So 7, negative 2, 4, negative 1, 3, 0, 4, 1, and 7, 2. Okay, let me plot those. So 7, negative 2 would be here. 4, negative 1 would be here. 3, 0, 4, 1, and 7, 2. So you can see I have a parabola going sideways. And if I draw in the line of reflection, which is the line y equals x, do my best, you can see that it does, that those points reflect over that symmetry line. Now, I want to remind you from geometry, that means like these points are the same distance to the line, and if you drew a line, between them, they would also be perpendicular to that line of symmetry. So again, inverse functions reflect over the line y equals x. All right, now what we can tell now by looking, is this inverse a function? So no, it's actually not a function, and the reason that is because we know that these values on the square root function we can't put in because we can't get outputs that are negative. So we actually have to restrict the domain. So if I want to make it a function, I can only look at the values where an x is 3 or greater, okay? All right, but there's a trick to tell if an inverse has a function, if an inverse of a function will be a function without even finding the inverse. Like I could tell that this function, I knew its inverse was not going to be a function unless I restricted the domain. And we do that using not the vertical line test, but we use the horizontal line test. I want you all to think about why that makes sense. Okay, I want you to think about what inverses are, what we do to the x's and the y's, and why a horizontal line test would tell me, meaning if I draw a horizontal line through this, why that would tell me whether or not its inverse is a function. Okay, we're going to talk about that tomorrow in class. All right, so as a kind of recap, these are the things from the 3 videos you should be able to do. You should be able to find an inverse from a table. So meaning I give you, 1, 3, 2, 5, 7, 12. Remember, to find the inverses, we flip the x's and the y's, okay? you should be able to find an inverse function equation. So if I give you y equals, I don't know, 2x plus 1, we know that we flip x and y, and we solve for y. So we get inverse functions. We should be able to explain if two functions are inverses of each other, and you're going to do that using the composition of functions. Remember, if f of g of x equals x, and g of f of x equals x, then the functions are inverses of each other. You should be able to graph inverse functions by reflecting them over the line y equals x. Again, you could make a table and flip the points as well. And you're going to want to be able to tell if a function graph has an inverse that is a function. So you're going to have to understand and explain why the horizontal line test will do that, okay? So that's just a little bit about inverse graphs, okay? Again, they reflect over the line y equals x. It's a beautiful, nice symmetry within that line. And I want you to be able to explain to me tomorrow why the horizontal line test makes sense, okay? All right, everybody have a great day.